Reactions that release energy are called exothermic reactions. I remember this because exo reminds me of exit. Energy is exiting. Another point is that the delta H value is going to be negative in an exothermic reaction. The opposite of an exothermic reaction is an endothermic. I remember this because endo sounds like in, as in energy goes in. So the delta H value of this type of reaction would be a positive number. True or false, the law of conservation of energy states that energy can be created or destroyed in an ordinary chemical process. That is false, because energy cannot be created or destroyed. That's the conservation of energy. If it's conserved, that means it's not created or destroyed. And then finally, thermochemical equations are equations that indicate the amount of heat, energy absorbed or released during a chemical reaction. And that's what I'm talking about when I say the delta H value. So it's a number and an equation that tells how much heat energy is given off. The equation might look like A plus B yields C plus D plus your delta H value, which might be 29.2 kilojoules. So for question number 6, I'm starting with 800 grams of SO3. And I need to find out how many kilojoules are given off. Now I can't go directly from grams to kilojoules, but I could convert grams to moles. And once I figure out how many moles, I know that there's 129.6 kilojoules for every 1 mole of sulfur trioxide. So I could go from moles to kilojoules. So for question number 6, I'm starting with 800 grams of SO3, and I can convert grams to moles. And once I know how many moles I have, I can find out how many kilojoules it would take to convert that. My conversion factor for this last step right here, going from moles to kilojoules, is going to be that 1 mole of sulfur trioxide creates 129.6 kilojoules of energy. So let me write this down on the side. 1 mole of SO3 is equal to 129.6 kilojoules. So this right here is enough information. That's my plan. Now I need to convert from 800 grams to find out how many kilojoules I would get. So 800 grams is going to be multiplied first to get rid of grams and to have moles be left over. I want grams to cancel out. I'm going to put grams of SO3 on the bottom, and I'm converting it to moles of SO3. I know that 1 mole has a mass. Looking at a periodic table, I have sulfur plus 3 oxygens. The mass of that is 80 if I add up those masses from the periodic table. At this point, grams of SO3 will cancel. My only unit is moles of SO3. And I want to go one more step and convert from moles of SO3 to kilojoules. How many kilojoules are given off by those moles? My question says, for every mole of sulfur trioxide, 129.6 kilojoules of energy are released. That's a conversion factor. And I've written it right here. So, 1 mole of SO3 gives off 129.6 kilojoules of energy. At that point, it's a matter of multiplying across and simplifying, and you would find about 1,200, and I got 96 kilojoules. So this answer that's given is a little bit off, but it's very close. If you do the math, you get 1,296 kilojoules. So let's do another example problem together. Number 7 says, when 21.95 kilojoules of energy are added to 1 mole of carbon dioxide, it will produce carbon monoxide and oxygen. Step number 1 is to write the thermochemical equation. So I'm remembering that the thermochemical equation is both the balanced chemical equation plus my delta H value, so plus a number in kilojoules, and determine how many kilojoules of energy are needed to decompose 100 grams of carbon dioxide. So that part is going to be a conversion problem. So let's start off with our equation. I have carbon dioxide, and energy is getting added to it. That tells me that this is an endothermic reaction if energy has to go in. So my reaction is, I have CO2 plus, I'm going to leave some space right here for my energy that goes in. I'll fill that in just a moment. So CO2 plus that energy will create carbon monoxide and also oxygen gas. I need to balance this equation before I can go to the next step. I'm noticing that I have 2 oxygens here and 1, 2, 3 oxygens on my product side, which is not going to work. I have an odd number of oxygens over here. This will always be even. So I'm going to multiply this by 2, which will give me 2 carbons and then 4 oxygens on my product side. To get that over on my reactant side, I'm just going to put a 2 out front here. So there's my balanced equation. The last step, though, is to make it a thermochemical equation. I need to add the fact that there's 21.95 kilojoules of energy for every 1 mole of carbon dioxide. Now I have 2 moles of carbon dioxide. So if I take this number, 21.95, and I multiply it by 2, my calculator is telling me 43.9, squeezing it in, kilojoules of energy will go into my thermochemical equation. Now let's look at the next part of the question. It says, how many kilojoules of energy are needed to decompose 100 grams of carbon dioxide? So this is simply a conversion problem. I have 100 grams of CO2, and I need to convert that in such a way to find out how many kilojoules go with 100 grams. Well, I can't go directly from grams to kilojoules. I need a middle step. I need to find out how many moles there are. And then I can go from moles to kilojoules by using the conversion factor that the equation, that the question tells me. So let's try that. I have 100 grams of CO2 and I want grams to cancel out. On my next fraction, I'm going to put grams of CO2 on the bottom. I'm changing from grams to moles, so I'm going to write moles of CO2 up top. I know, looking at a periodic table, that 1 mole of CO2 has a molar mass of, carbon is 12, oxygen is 16, and there are 2 oxygens there. So if you add that all together, you get 44 grams for CO2. Grams cancels. Now I want moles to cancel out, and I want to be left with kilojoules up top. So the question tells me 1 mole of carbon dioxide takes 21.95 kilojoules of energy. That's a conversion factor. Those are the numbers that I can use to fill into this fraction right here. So for every 1 mole of CO2, we would have to put in 21.95 kilojoules. So if you go ahead and simplify that and calculate it out on your calculator, you would get, I got 49.89 kilojoules of energy, or what it would take to break down that much CO2. I'm going to do one more example with you. I'm actually going to skip number 8. You're welcome to try that one on your own. Note that the answer that's provided here is actually incorrect. That's a typo. I think it ends up being 1-point-something kilograms, but it's not 1.53. So if you want to try that one on your own, you're welcome to. I'm going to jump right to number 9 to do with you. 9 says, magnesium combines with oxygen to form magnesium oxide. The enthalpy change to the delta H value is negative 1,204 kilojoules. Now the fact that it's negative tells me that it's exothermic. We wrote that at the very top of this page of notes, that exothermic would have a negative value. Our directions say to write the balanced equation for this reaction and then answer questions. So let's start with our equation. We have magnesium combining with oxygen. Oxygen is diatomic, it's always O2, to form magnesium oxide. Magnesium has a charge on a periodic table of +2, oxygen is -2, so those go together perfectly. I don't need to write any subscripts. But I do need to balance this out. 2 oxygens over here, so I need a 2 in front of my product, meaning that I would also need a 2 in front of my magnesium on the reactant side. One last thing it tells me is that the enthalpy change is as an exothermic reaction. Energy is coming out on the product side, and we have 1,204 kilojoules that come out. So there is my thermochemical equation. A says, is this reaction exothermic or endothermic? Well, the fact that energy is coming out, plus the question had a negative number initially, that tells me that it is exothermic. B says, to calculate the amount of heat transferred when 2.4 grams of magnesium react at constant pressure. So I need to find out how much heat is transferred in kilojoules if I start with grams. So I'm going to go from grams to moles to kilojoules. There's my plan for solving this equation. I'm starting with 2.4 grams of Mg. I'm going to multiply it by 2 fractions to convert and get my final answer in kilojoules. Fraction number 1 is going from grams to moles. So to go from grams to moles, I want grams to cancel out. I'm going to write it on the bottom of my first fraction, grams of Mg. And then up top, I'll write moles of Mg. 1 mole of magnesium, if I look on the periodic table, weighs 24 grams. Next up, I want moles to cancel out, and I want to convert to kilojoules. So I'm going to put kilojoules up top, I'm going to put moles of Mg on the bottom to have it cancel. And my question tells me, my equation that I just wrote says that for every 2 moles of magnesium, I create 1,204 kilojoules. So let's fill those numbers in. 1,204 kilojoules for every 2 moles of magnesium. If you go ahead and plug those numbers into your calculator, you are going to get about 59 kilojoules. 59 kilojoules are transferred if you started with 2.4 grams of magnesium.